C.3, string matching problem. So this is a simple but good example for this brute force method. All right, actually for this method, other than the brute force method, there is a much more advanced, very powerful method. But that method is extremely complicated. So if I have a chance, I may talk about, but that method in our textbook, but very, very difficult to understand. But the brute force method, so simple, very easy to apply. Everyone can get it easily. All right, so for this video, so let us learn the brute force method. All right, first, our problem. In this part, this video, I want to talk about one special topic, mathematical representation. The importance of mathematical representation of a particular problem. In this one, it is important. Our problem number 6, string matching. Given a string of n characters, so we call that text. We have a text terminology for this problem. And a string of m characters, we call a pattern. Another string, smaller string, we want to, try to search in the text to match a given string, given pattern. All right, and m less than or equal to n. If m greater than n, there is no solution. So that's why we assume m less than or equal to n. Find a substring of the text that matches the pattern. You can see this is a basic question, basic problem, but it is very useful for the search operation, right? Search some special keywords in a document. Think about that. How many times people need to use this basic operation in the real world experience? So you can see, so useful. All right, so here we want to find the location of the pattern, location of the substring. Because the pattern is a fixed string. Now in the given text, we want to find location of the first substring that matches the given pattern. But how do you define the location? Right? What do you mean the location? You need to define it. Here. The index I of the leftmost character. Leftmost character. Not the rightmost character. Not somewhere in the middle. So the leftmost character. All right. First solution. Straightforward. The second solution, we may not have chance to do it in this class. So complicated. We may not have chance to do it. All right. Let's do the mathematical representation. How do you represent text? Right? You want to use a special way to represent the text. Because if we can represent this question mathematically, then we can apply mathematical tools. So we can do a lot of operations on those representations. All right. The text, we use a sequence of symbols with subscripts. The subscripts correspond to indices. Array of characters, the indices of those characters. All right. Pattern, another sequence of characters. We use P sequence with their subscripts corresponding to their indices. Yeah. So you can see the first part of representation. The second part, the requirement part, find the location I such that. How do you describe a match of a substring to the pattern? How do you describe that? Yeah. That's easy. Yeah. You can find some location index I such that T of I equals the first character in the pattern, P0, ... So in this way, consecutive comparison, matching, consecutive matching, right? T sub I plus j equals P sub j, and so on until you reach the last character in the pattern, T sub I plus m minus 1 equals P sub m minus 1. Okay, so that is the mathematical representation for the match. Now, with this description, we can start solving the problem. All right. To solve the problem, here I want to introduce another commonly used strategy. What's that? Guess and verify. In our real life, we do this many, many times. Yeah, it happens frequently. Guess and verify. First, you try to guess the answer. Yeah. But your guess many times may not be correct, incorrect. Yeah. So you need to verify it. You cannot skip the verify step to make sure it is correct. Yeah. But when you do the verification, you may find some incorrect things in your guess. So you need to make adjustment to make it correct. Okay? So that kind of methodology we use frequently in our real-world experience. Here, let me apply it in this simple question. We use this simple question, but we learn some important strategies, methods. All right. Thinking. All right. The question: can we exhaust all such M substrings? Yeah, we call that M substring. A substring with M characters. A substring with M consecutive characters. Yeah, when we talk about substring, usually they have to contain consecutive characters. Yeah. So a substring with M characters in the given text. M substrings. Can we exhaust all M substrings? Yeah. Yes, we can. Yeah. Every time we extract an M substring from the text with consecutive characters. Yeah. So must be consecutive characters. Yeah. To compare it with the pattern, given pattern, for a possible match. Okay, possible match. All right. So that's the brute force method. Okay, that's the brute force method. So if you can do it, you solve the problem. Yeah. All right. First, let's ask this question: how many such M substrings? How many such M substrings? Yeah. Because we want to do efficiency analysis later. So we want to ask this question: how many possible M substrings can you find in a given text with N characters? All right, here let us apply guess and verify strategy. Okay, guess and verify strategy. Yeah. So given a text, when you start, you compare the first substring with m characters. Okay? Then you shift one position to the right, second substring, and so on. At the end, you reach the last m substring at the end. So the text has n characters. Can you guess how many substrings by that kind of shifting operation from beginning to end can you find in the given text? Can you imagine that? Yeah, guess. So based on your intuition, I think you can guess easily. Yeah. The first guess, n minus n. Well, because when we do shift, yeah, that string, because the last character starts from some place, the last character moves from some location, not the beginning of the character, already some character in the middle, so then you move one by one to the end, so the total n characters, but minus the portion before the last character, right? So it is based on intuition. Some of you may guess n minus m. All right? Yeah. Your guess may not be correct. Okay? So when you make this guess, it may not be correct. So you need to verify it to make sure it is correct. So if it's not correct, you need to make adjustment. Here, let us do it. We need to verify it. Okay? Yeah. So when we verify it, we want to use a simple case. Yeah. As simple as possible to verify it. Okay? So what kind of simple case we want to use? M equals n. The extremal case, the number of characters in the text and the number of pattern, they have the same number of characters. In that case, you only have one m substring, right? Only one. So the answer is 1. Yeah. But by this formula, the subtraction number is 0, right? 0. So different from that 1. So that means your guess is incorrect. So you need to make adjustment to make it correct, right? So after you do the adjustment, you need to add 1 to your guess. After you add 1 to your guess, so this case works. That extremal special simple case works. So that means you fix the problem in your guess. Right? So the answer is n minus m plus 1. Yeah. So that's the way we use this guess and verify strategy. Yeah. All right, next, implementation details. How do we implement the whole search procedure? Yeah. Very simple, very straightforward. But here, although it's simple, but I want to introduce you another special method, very useful method in our problem solving. Yeah. Very useful. Yeah. All right. So let's look at this. Yeah. So suppose this is our text. Yeah. All right. So when we start process our first m substring, the starting location index, the first one, I equals 0. So this is our first location when you start to work on your first m substring. It's easy, the answer, but the question is, what is your last location? We need to find the last m substring, the leftmost. So this is the leftmost index of your last m substring. But what's that? That looks not that obvious, right? That looks not that obvious. Yeah. So here, we want to figure out what is the exact number of that subscript. Okay, yeah. Here, I want to introduce you a very important method in problem solving in this situation. So what's that? It is called invariant idea. Invariant idea. So this is pretty abstract, invariant idea. So what's that? All right. So when you work on a problem, sometimes you need to keep track of some special quantity, but it is not easy to keep track of that quantity. Then you need to discover some invariant property. You use the invariant property to help you keep track of some special quantity. So the idea is pretty abstract, but here let me use this example to explain how do I use this invariant idea to find location of the last M substring. All right. So first you need to discover the invariant. What's the invariant? Difference of two end subscripts of each substring. All right. Here, think about it. You move an M substring different locations in the text, right? So when you move, which quantity never changes? Which quantity never changes? That's the invariant we want to use. There is one quantity never changes. The difference between the last subscript of the M substring and the first subscript of the M, that difference never changes, because that difference reflects the number of characters, right? Plus one, but it is a fixed number, right? So when you move, that difference never changes. So we discover that quantity. So we use that quantity to help us keep track of the, starting index of each M substring. That's the idea. So let me apply it here. All right. First, the difference of two end subscripts. So we call two end subscripts. That's N minus 1 for the first M substring. Then let's look at the difference of the last M substring. M minus 1 minus X, because X we don't know, that question mark, that number, we don't know it. We don't know it. So we use X to represent it. So we want to find the X value here. All right. And based on our observation, these two noun expressions must be equal. Based on our observation, right? So we set up equation like this. Then we can solve this equation for X. That is, X equals N minus M. N minus M. Okay? So you can see we use this invariant idea or approach to find the answer. Later, we will use this idea several times in this course. All right. All right. So we get that last number. So you know it. With this number, we can do the analysis of the efficiency. All right. So here, let me just put the efficiency number, because pretty simple to understand. Best case efficiency, you only need to do M comparisons, because the best case, the first substring when you check, you'll find a match. That's the best case. You only check one M substring, you need M comparisons. Worst case, you need to keep checking until you reach the last M substring. All right? So you need to check this many substrings n minus m plus 1. Yeah. Because you count from 0 to that number. 0 to n minus 1. So there are n minus 1 plus 1 substrings. M substrings. Yeah. Each substring you need to do this many comparison. So you do the multiplication. Yeah. So you have that. Average case efficiency, also very easy, plus divided by 2. Yeah. Although, remember, average case, we need to consider all the possibilities, but even you do that, you're adding the total number of comparisons divided by the total number of cases, you get the same expression. Okay? You get the same expression. Yeah. So that's the solution for this problem. So we solve it. Yeah. Straightforward brute force method. Yeah. All right, so we complete this video and also complete this part C of module 2. Yeah. And the whole module also complete. Yeah. So next time we will start module 3.